Today we are diving into a really strange problem with USB-C network adapters. A problem that completely ruined my first tests with the Kudi P5 and the Pointing X POL24 antenna. I spent the whole day trying to figure out whether the issue was antenna direction or something else entirely. I moved the antenna, recalibrated, retested, and nothing made sense. Only at the very end I realized I should check the USB-C adapter. And that is where everything fell apart. All three adapters have always worked perfectly on macOS. Then macOS 26 arrived and suddenly the performance collapsed. Two adapters became unusably slow and one survived for unknown reasons. Before we begin, let me know in the comments if you have had any USB-C adapter issues or what could cause these problems. And remember to subscribe for more 5G router testing and troubleshooting content. We begin our testing with the Bluecloud adapter connected first to the MacBook. Right away we see that the performance is far from what it should be. With this setup I expect downstream speeds close to 150 megabits per second, but we are nowhere near that value. Something is clearly wrong. To verify that the adapter itself is not the problem, I connect it to my 2.5 gigabit local LAN and run OpenSpeed test. Here the performance is much better. Not perfect, but completely acceptable for a budget adapter. In other words, the adapter works fine on local traffic. The bottleneck only appears when connected to a 5G router. Next we move to Windows 11 using a Lenovo laptop. The behavior is identical. When connected to the 5G router, speeds drop dramatically. But again, on the LAN side, the performance is normal, although not quite as good as on macOS. At this point it becomes clear that the adapter is not defective. Something else must be causing the 5G slowdown on both operating systems. Now here is where things get interesting. On Windows we can actually examine the network adapter properties, and this is where we discover the probable cause. The default buffer values are very low for some reason. These are the values Windows sets automatically when a new adapter is connected. After increasing both buffers to their maximum values, the LAN speed does not change much. However, when I reconnect the adapter to the 5G router and run the test again, the performance instantly jumps back to the expected level for this base station and frequency combination. That is a huge difference caused purely by buffer size. So the Bluecloud adapter works perfectly on LAN and on Windows once the buffers are adjusted. But on macOS 26 the slow 5G performance remains, which raises even more questions. Next we move on to the Belkin adapter, and the pattern continues immediately. Starting with macOS connected to the 5G router, we see exactly the same behavior as with the Bluecloud adapter. The performance is clearly below what it should be and nowhere near stable. When switching to LAN and running OpenSpeed test, the performance returns to normal levels. So once again the adapter itself works perfectly fine on local traffic. The problem appears only when macOS 26 communicates with the 5G router. Next we test the Belkin adapter on Windows 11. And just like before, 5G performance is seriously limited while LAN speeds are totally acceptable. This confirms the issue is consistent across both operating systems when using default settings. Previously it was a bit unclear which chipset Belkin used in this model, but during this test we confirmed that it uses the same Realtek chipset as the Bluecloud adapter. In other words, these two devices are technically identical, and unsurprisingly, they both behave in the exact same way. Just like in the first test, Windows assigns very low buffer values by default. Increasing these to their maximum values and restarting Windows restores full 5G performance again. After the adjustment, the adapter behaves exactly as expected and matches the performance of the Bluecloud device. This confirms that the chipset is not the issue. The problem is clearly related to default system settings and, in the case of macOS 26, possibly deeper OS-level network handling changes. The final adapter in this comparison is the Club 3D, and this one is a bit different from the previous two. It uses a newer Realtek chipset that supports 5 gigabit connections, so in theory it should offer better performance. And right from the first macOS test we see something unexpected. This adapter actually works correctly out of the box with the 5G router on macOS 26. No speed drop and no strange behavior. Next we run the LAN test, and as expected it performs slightly better than the older adapters. The newer chipset clearly helps here. This is the strongest LAN performer so far. Moving to Windows 11, the familiar pattern returns. Connected to the 5G router, the performance drops significantly, even though the LAN test shows completely normal behavior. Again, the Club 3D is the fastest device on LAN among all adapters tested. Checking the adapter settings reveals the same issue we have seen before. Windows assigns very low default buffer values. Exactly the same behavior as with the Bluecloud and Belkin adapters. We increase both values to maximum and run the tests again. As expected, Windows now delivers full 5G performance. One interesting finding appears after increasing the buffers. When running the LAN test again, the Club 3D is only adapter where buffer tuning affects local network performance significantly. So on macOS this adapter works perfectly without any changes, while on Windows it needs the same buffer fix as the others. To summarize the entire set of tests, there are 4 key findings. First, macOS 26 seems to introduce a problem that affects most USB-C network adapters when used with 5G routers. LAN performance remains completely normal, but 5G speeds collapse without any clear explanation. Second, Windows 11 has its own issue. It applies very low default buffer settings to new network adapters. This results in the same poor 5G performance, but unlike macOS, the fix is simple. Increasing both buffer values to maximum restores the full expected speed. Third, the Club 3D adapter is the only model that works correctly with macOS 26 when connected to a 5G router. Its newer chipset seems to avoid the macOS bottleneck entirely, although it still needs the same buffer adjustments on Windows. And fourth, this behavior is not related to any specific 5G router. I tested this with devices from ZTE, Huawei and QD, and the results were identical. Every router produced the same symptoms across all tests. Thank you for watching this deep dive into one of the strangest performance issues I have come across. If you found this helpful, remember to hit the like button and subscribe the channel. If you have any theories about what changed in macOS 26 or why these issues appear only with 5G routers and not local network? Please share your thoughts in the comments. And don't forget our new Discord community. Link is on the description. Thanks again for watching and see you in the next 5G benchmark video.